All right, students, let's do our 2.5. And in that, we will be graphing the quadratic functions, but we will be changing them from standard form to vertex form because without um, doing that, it's pretty much not possible to graph them. So let's get started. In that, it's talking about that Optima's niece, Jenny, who also works on her math homework while she's working in the shop. So she is figuring out that there is a pattern or there's a connection between how you make the quilt blocks and how you graph the quadratic equations. So here she has to graph this y equals x, take away 3 square of that, 4. She has to graph it without using calculator. So how would she do that? Think about it. Earlier we said that y equals a times x minus h square of that plus k is the vertex form, where h and k is the vertex and a is the stretch factor. So, and we also talked about that this decides if it the graph will be moving left or right, and this decides if the graph will be moving up or down. Now, since we have this -3, that means it will make the graph move to the right. So because it's negative, when this is negative, it makes the graph move to the right. Okay, and then this positive 4, okay, this moves the graph up because it's positive. That's why it moves it up. If it was negative, then it would have moved it down. Then its vertex will be, so look how you have negative here, so you have to keep the negative. So that's why the vertex will be 3 and 4. Okay, now let's graph it. So if we say that this is your y axis and this is your x axis, then if we so this is our vertex. First, let's graph the vertex. So it's 1, 2, 3, and then 1, 2, 3, 4. So this will be the vertex, 3 and 4. So you can see it moved it 3 to the right. Otherwise, we would have gotten our vertex here. So we moved 3 to the right. So 1, 2, 3, and then 4 up. So 1, 2, 3, 4. So this is the vertex right now. And then again, we go 1 up. So we are going 1 up for the next one. Then we go 3 up for the next one. So 1, 2, 3. And then for this one, 1, 2, 3. And then for the next one, you will be going 5 up. So 1, 2, 3, 4, 5. So pretty much here. And then 1, 2, 3, 4, 5. So pretty much here. Then you connect it. And this is how your parabola will move up. Um, by 4 and right by 3. Okay, so this is how you graph it without using the calculator. Now let's do the second one. Okay, and in that, so she goes back to her homework, and this time she has to graph this. Now, this is in the standard form. So we talked about that this was vertex form. Now, this is a standard form, and standard form looks like y equals ax squared plus bx plus c. Now, this cannot be 0. It can be any number but 0. Why? Because if this is 0, then you will not have x squared term and it won't remain a quadratic equation. It will become a linear equation that only has x in it. So if you want to have a standard form of your quadratic equation, then you have to have a as non-zero number. It can be anything but 0. Okay? So now she has to graph this. The only way she can graph it if she changes that looking like this, which she figured out that if she can make it a perfect square, like she has to write it down as the factor and square of that. So then only in that case, she will be able to graph. So let's change it to vertex form by um, doing the perfect square of it. So again, we will be doing same thing. You have one of the x squared, so you will be needing just one box. And then we have negative 6, so you will be splitting it into half. So 3 of them will be going here and 3 will be going here. So you will have negative 3 here, negative 3 here, and then you will have x here, that will make it x squared. This will be negative 3x, this will be negative 3x, and this will be 9. Okay, so which it is, so we can right away write it down as x minus 3 and square of that. Okay, so this is how she changed it into a vertex form by completing by by doing the making the perfect square of it. So here she is now. um, the new form of equation is nothing but y equals x minus 3 and square of that. If you compare this with y equals a times x minus h and square of that k, then you will see that a is 1, so the stretch factor is 1. So we will be going in 1 up, then 3 up, and then 5 up. Okay, this is how it will be moving. And this h is 3 in this one. So vertex will be 3. And there is no k in this one. That means it's 0. So the vertex is 3, 0. Now when you graph it, you will say it is moving. So initially, if, so first let's figure out the axis. So this is your x-axis and this is your y-axis. Now, if we had the initial vertex um, position, that is like 0, 0, but we are moving because this is moving it 3 to the right. So your vertex is 3, 0 now, which is 1, 2, 3. So right here. Y is 0 for it, so it's right here. Now you will go 1 up on both sides because your stretch factor is 1. So now you'll be going 3 up. So 1, 2, 3, and then 1, 2, 3. Now you'll be going 5 up for the next one. So 1, 2, 3, 4, 5, and then 1, 2, 3, 4. Now you will be connecting it. So this is how your hold on. So this is how your parabola will look like. So these are the points, and this is the parabola. Now let's do next one, and in this one, she has this problem where she has this equation. Okay? Now, can we make a perfect square of it like we did in this? So let's find out. So in that case, you will be making your box, and then you will be splitting your 4x into 2x and 2x. So 2x will, so this is your 2x and this is your 2x. So you do 2 and 2. It will be plus because these are positive, and then this is your x squared, so x. Now if this is 2 and this is 2, so this will be 4. You will be needing 4 of those, but you only have 2. So right now we will say now this is only asking that is it possible to write it down as perfect square. So we will say we can't we can't write the perfect square since we have 2 as a constant, not 4. Because we need 4, but we only have 2. So then it is asking use the area model to figure out, which we already did, and we figured out we will be needing 4. So if we write down y equals x squared plus 4x, you already have 2 and you need 4. So if you add 2 more, that will make it 4. But you cannot just add 2, you have to take away 2 so that you are not changing the equation altogether. So then if you put these together, it will become x squared plus 4x plus 4, take away 2. Okay. Now this is nothing but this in area model. So you have x squared, you have 2 and 2, so 4x, and you have 4. So instead of writing down as area, you can write it down as the sides. So you will say x plus 2 times x plus 2, which is square of that. And then you have this take away 2 outside. So this is how you will be writing it down as a vertex form. Now next one is it is asking is the equation you have written equivalent to the original equation? So we will say yes, they both are equivalent. Since we added and subtracted 2. So it kept the equation in balance. So we did not change the equation. It's just a different form of the equation. So this is same as that. Okay. Now that we have the equation, which is y equals x plus 2 square of that, take away 2. Now let's compare it with the standard vertex form, which is a x take away h square of that plus k. If you compare it, then we can find out the vertex of it. So the vertex will be, because there should be a negative here, but you have a positive, that means this is your -2. So your vertex will be -2 and k is positive, so this is basically -2. So your vertex is -2, -2, and your stretch factor A is 1. That means we will be going as 1 up, then 3 up, and then 5 up. Okay, so let's first find out, because we are going, our vertex is going this way down. So let's move our uh, axis on this side this time. Okay. So then so you can see we are going 2 to the left and 2 down. Okay, so that will make our vertex -2, -2. So 1, 2, and then 1, 2. So this is our vertex. Now you'll be going 1 up, so 1 up and 1 up, and then 3 up. So 1, 2, 3, and then 1, 2, 3. Then you have 5. So 1, 2, 3, 4, 5. And on this side also 1, 2, 3, 4, 5. So these are the points, and then you connect them. So this is how your um, parabola graph looks like. Okay. Now let's do next one, and in that um, she has to complete the square, but the problem is that B is a B is a odd number here. So B is an odd number. So that is a problem, because earlier we were splitting it in half. But when we are splitting this, it will become 7 over 2. But we can still continue. So we will be doing, so this is your x squared. Then when you do 7 over 2, then this will become 7 over 2x, and this will become 7 over 2x. So that will make um, this x, because together they are x squared. Then this, if this is x, then this has to be, and this is positive, so positive 7 over 2. And this will be positive 7 over 2. Now 7 over 2 times 7 over 2 will be 7 square and 2 square, which is 49 and 4. Okay? So we get 49 and 4. So then now what we will do is, together, if you add these two, then look at it, you have 7 over 2 and 7 over 2. If you're adding them, you have common denominator, so 2. So then you'll be adding 7 and 7, which is 14, and then you will get 7. So if you add these two, you get your 7x back. So this is x squared. This is 7x. It's just that you need this term. So this is how you will be writing it down. You will say gx, so x squared. If I put these together, like here, I get 7x back. So 7x. And then I have this term that I'll be needing to make the square. So we will do 49 over 4. And then because we added that, we have to take away the same term so that our equation is in balance. And then you have this extra 10 also, so we keep. So if we put this together, which is this whole thing here, then instead of writing it down as the area, I can also write it down as this times that. So we will be writing it as gx. For this whole thing, I will write down this times this, which is x plus 7 over 2 and square of that. Now, what is left is this take away 49 over 4, and then I have 10. Now, what I will do now is I will be multiplying it by 4 and dividing it by 4 so that I can get common denominators. So now I will be getting 49 over 4, and then this will be 40 because 10 times 4 and over 4. My denominators are common, so I can, and they're different signs, I can subtract 49 and 40, and I'll be getting take away, I'll be getting 9 over 4. And this is my vertex form of equation. So this is my vertex, this is x coordinate of it, this is y coordinate of it, and the factor, stress factor is 1. Okay, okay, so